Right now, as you are watching this, the heat dome that has been sitting over this country for weeks is finally starting to break down. And under almost any other circumstances, that would be the good news segment of this video. It is not this time, because what is moving in behind it is not a return to normal, calm summer weather. It is an active, severe weather pattern, aggressive enough that forecast outlook maps are shifting into categories most of you have never actually seen used. I have been watching this transition build over the last several days, and I need to walk you through exactly why the end of this heat wave is not the relief it looks like on the surface. Subscribe if you have not already, and turn on that bell notification, because this pattern is shifting fast, and I will be back with updates the moment anything changes. Let's get into it. Let's start with the mechanism, because understanding why this heat dome is finally collapsing is the key to understanding why what comes next is more dangerous than the heat itself. Well, the ridge of high pressure that's been anchoring this pattern has been sitting over the central and western United States, acting like a lid on the atmosphere and trapping hot air underneath it day after day. That's what produced the record-breaking numbers we've been tracking. Readings in Montana, Utah, and across the northern plains that broke marks that had stood for over a century in some locations. But a ridge like this does not hold its position forever. Two things are working against it right now simultaneously. First, the North American monsoon is strengthening, pulling increased moisture up from Mexico into the desert southwest and the Four Corners region. That added moisture disrupts the dry, stable air that a heat dome needs to sustain itself. Second, and more importantly for the rest of the country, the broader jet stream pattern is beginning to buckle, allowing the ridge to finally break down instead of holding its locked position. Here's the part that matters most. And when a heat dome like this finally collapses, the energy trapped inside that system doesn't just vanish quietly. It has to go somewhere. And where it goes is directly into whatever storm system arrives to replace the ridge. What maps turning black actually means. I want to explain this carefully, because this phrase gets thrown around online without much context, and the actual meteorology behind it is worth understanding rather than just reacting to. Two separate federal forecasting products use color-coded severity scales, and both of them top out in categories that are visually about as dark and alarming as a weather map can get. The first is the NWS HeatRisk system, which the National Weather Service developed jointly with the CDC. It runs from green, meaning little to no risk, all the way up through yellow, orange, and red, before topping out at a category NWS itself labels purple or extreme. That top category is reserved specifically for rare long-duration heat events offering little to no overnight relief. Conditions serious enough to affect anyone without adequate cooling, not just vulnerable populations, while also straining infrastructure and healthcare systems. We've already seen that top purple category appear across a wide swath of the Midwest, Ohio Valley, and Northeast during this pattern. The second, and the one that becomes relevant as this heat transitions into storms, is the Storm Prediction Center's convective outlook scale. That scale runs from marginal risk up through slight, enhanced, and moderate, before reaching its own top category, labeled simply high risk. The high risk designation is one of the rarest forecasts issued by the Storm Prediction Center, which reserves specifically for setups expected to produce numerous intense, long-track tornadoes or thunderstorm complexes capable of producing hurricane-force wind gusts across a widespread area. On the standard SPC color scheme, that category renders in a dark magenta that, depending on the display and lighting, reads as close to black on many screens, which is exactly the visual people are referring to when they say the maps are turning black. This designation gets used only a handful of times per year, and when it has been used in recent years, the outcomes have consistently matched the severity of the forecast. The Storm Prediction Center's high-risk call ahead of the May 2024 Kansas and Oklahoma tornado outbreak preceded dozens of tornadoes, including one that reduced entire sections of Barnsdall, Oklahoma to rubble. Their high-risk call over the Mississippi River Valley in March 2023 preceded a roof collapse at a concert venue in Illinois that killed one person and injured dozens more. Part of an outbreak that ultimately produced 146 confirmed tornadoes, the third largest outbreak on record in the United States. When you see a forecast outlook map shift into that top category, it is not a marketing exaggeration. It is one of the most serious warnings the federal government's severe weather forecasting system is capable of issuing. The storms already arriving. This week. This is not a hypothetical future tense pattern. It's already playing out. As this heat dome has weakened, severe weather alerts have already gone active across parts of the country experiencing the transition first. In the Nashville region, specifically, forecasters issued an alert for a line of storms expected to develop through the afternoon and move south-southeast into the overnight hours, with damaging winds, heavy downpours, and hail as the primary threats, and a low but real tornado chance flagged for areas northeast of the city into Kentucky. On the setup driving that threat, the hottest day of the week ahead of the frontal passage, combined with high dew points and an approaching line, is a textbook example of exactly the energy release pattern we described above. The heat builds to its peak right before the front arrives, and then all of that stored atmospheric energy gets converted into the fuel for severe convection. This is the pattern to understand for the days ahead. It will not be uniform severe weather, blanketing the entire country simultaneously. It will be a rolling sequence. One region hits peak heat, a front arrives, that heat converts into a severe weather event, the front passes through and temperatures drop noticeably behind it, and then the process repeats a few days later somewhere else along the same corridor. Forecasters in the Nashville example specifically noted that conditions would be noticeably cooler behind the front, with a taste of early fall-like air arriving within 24 hours of the storms clearing out. That whiplash from the hottest day of the week straight into a sharp cool down is exactly what happens when a heat dome's stored energy gets discharged through a significant severe weather event rather than fading away quietly. Here's the piece of this that I think deserves more attention than it usually gets. People tend to think of a heat wave and a severe storm outbreak as two separate hazards you deal with one at a time. In a pattern like this one, they're not separate. They're connected stages of the same event. And the connecting moment, the actual transition, tends to be the most volatile part of the entire sequence. The reason comes down to atmospheric energy. A heat dome spends days, sometimes weeks, building up warm, moist, unstable air at the surface. That instability is essentially stored potential energy, fuel waiting for something to ignite it. When a cold front or a shortwave trough finally arrives strong enough to break the ridge down, it doesn't gently ease that stored energy out of the atmosphere. It slams into it. The greater the temperature and moisture contrast between the retreating hot air mass and the incoming cooler air, the more violently that stored energy releases, and the more severe the resulting storms tend to be. This is precisely why the most significant severe weather outbreaks in the historical record so often follow directly on the heels of a prolonged, intense heat wave rather than occurring during an otherwise unremarkable stretch of weather. The July 2024 severe weather sequence that produced 94 tornadoes in a single continuous outbreak, a record for that time of year, along with two separate derechos producing wind gusts over 100 miles per hour, developed in exactly this kind of setup, a hot, unstable air mass finally getting broken down by an advancing frontal system. So when you hear that a heat wave is ending, the instinct is to treat that as good news outright. Based on how these patterns actually behave, the more accurate read is that the hazard is changing shape, not disappearing. And in many cases, the transition period itself carries more risk of severe, damaging weather than the heat wave did on its own. Since the historical comparison above referenced derechos specifically, it's worth explaining exactly what that term means, because it's one of the more serious threats that can emerge from precisely this kind of heat-to-storm transition, and it doesn't get the same public recognition that tornadoes do despite being capable of comparable damage. A derecho is a widespread, long-lived windstorm produced by a fast-moving band of thunderstorms, technically defined as a swath of wind damage extending more than 250 miles, with wind gusts reaching at least 58 miles per hour along most of its length, and several isolated gusts reaching 75 miles per hour or greater. Unlike a tornado, which does concentrated, narrow-path damage along a specific track, a derecho does damage across an enormous, continuous swath, essentially a straight-line wind event on the scale of a hurricane's wind field, but moving overland at speeds that can outrun a car on the highway. Derechos form specifically in the kind of setup we've been describing throughout this video, where a large, unstable, moisture-rich air mass, the exact conditions a multi-week heat dome leaves behind, getting hit by a strong forcing mechanism capable of organizing that instability into a fast-moving, coherent line, rather than a scattered handful of individual storms. That's precisely why the two derechos embedded in the July 2024 outbreak we referenced earlier, one producing 109 mile per hour gusts in South Dakota, the other producing 105 mile per hour gusts in Illinois alongside nearly 8 inches of rainfall in a single location, developed directly out of a heat-primed air mass rather than an already active severe weather pattern. If a derecho tracks through a populated area, the damage profile looks less like a tornado's narrow devastation and more like a widespread hurricane aftermath. Extensive tree damage, downed power lines across an enormous area, structural damage to roofs and outbuildings, and power outages that can affect hundreds of thousands of customers simultaneously, sometimes for the better part of a week. Because the damage is so spread out rather than concentrated, mutual aid and repair crews from unaffected neighboring areas, the kind that typically speed up recovery after a tornado, aren't available in the same way, since the entire regional grid took damage more or less at once. Emergency managers in regions that have experienced a major derecho often describe the recovery timeline as closer to what a moderate hurricane leaves behind than what a typical severe thunderstorm produces, precisely because of how far the wind damage extends in a single continuous event. The bigger seasonal pattern behind all of this. It's worth stepping back and placing this heat to storm transition inside the broader context of what's been an unusually active summer overall. This year's pattern has been shaped significantly by a developing El Niño, one that forecasters have said carries the potential to strengthen further into what's sometimes called a super El Niño later in the year. Seasonal outlooks issued before this summer even began specifically flagged the combination we're now watching play out in real time. Near to above average tornado activity from the plains through the east coast, paired with a hot, energy-loaded atmosphere capable of fueling that severe weather once the right trigger arrives. That's part of why this heat dome has behaved so differently from a typical summer ridge. Rather than building once, peaking, and gradually fading through the back half of summer the way ridges often do in an average year, this pattern has cycled repeatedly, shifting from the eastern half of the country to the western half and back again multiple times since late June, each cycle discharging its stored energy through a fresh round of severe weather before rebuilding somewhere else. The transition we're describing right now, heat collapsing into an active, severe weather stretch across the central and eastern U.S., is very likely just the latest cycle in that same repeating pattern, rather than a one-time event marking a clean end to summer's volatility. Who should be watching this most closely? Given the pattern currently in motion, the regions with the most reason to stay alert over approximately the next 1 to 2 weeks are the same corridor that just came out of the most intense heat. The Central Plains, the Mississippi and Ohio valleys, and the Midwest. As the retreating heat dome hands off to a more active storm track passing through behind it. As this pattern progresses, that severe weather threat is expected to work its way toward the mid-Atlantic and Northeast as well, on the same general corridor that experienced the worst of the earlier heat dome episodes this summer. If you're in any of these regions, this is the moment to actually set up your severe weather plan rather than waiting for a specific warning to force the issue. Know where your safest sheltering spot is, away from windows, ideally in a basement or an interior room on the lowest floor. Make sure you have a way to receive warnings that doesn't depend on being awake and looking at your phone, since a meaningful share of tornado fatalities happen during overnight events when people are asleep and don't get the warning in time. Keep your phone charged and consider a backup battery, since these storm systems frequently take down power alongside producing damaging winds. This overnight risk deserves a bit more explanation, because it's one of the more counterintuitive parts of severe weather safety. Nocturnal tornadoes are disproportionately deadly compared to tornadoes that strike during the day, not because they're inherently stronger, but because the entire chain of protective behavior, hearing a warning, seeking shelter, moving away from windows, depends on people being awake and alert enough to act on it. A daytime tornado warning reaches people who are up, mobile, and watching television or checking their phones throughout the afternoon. The same warning issued at 2 a.m. reaches people who are asleep. And unless they have a weather radio or a phone alert specifically configured to sound an alarm loud enough to wake them, that warning can go completely unnoticed until the storm has already arrived. Given that this transition period is producing storms, moving through in the evening and overnight hours in places like the Nashville example we described, this is exactly the kind of setup where making sure your overnight alert system actually works, tested, with the volume up rather than assumed to work, genuinely matters. And the good news, if there is a clean piece of good news buried in this pattern, is that a transition like this one is typically not permanent. Once the retreating heat dome's energy has been discharged through this active stretch of severe weather, the broader pattern tends to settle into something closer to average conditions for a stretch of days or weeks, at least until the next ridge has time to rebuild. But given how many times this exact heat dome rebuild cycle has already repeated itself this season, cycling from east to west and back again multiple times since late June, it would be a mistake to assume this is the final chapter. The same set of atmospheric ingredients that produce this summer's repeated heat domes are still present in the broader pattern, which means another rebuild remains a real possibility later in the season rather than a settled certainty that summer's worst is now behind us. It's tempting to hear that a punishing multi-week heat wave is finally breaking down and treat that purely as relief. In a normal year, that instinct would usually be correct. This year, the transition itself is carrying real severe weather risk. Forecast maps shifting into categories reserved for the most dangerous tornado and wind events this country sees, and storms already active in places like Nashville as this pattern begins its handoff. The heat is ending. What's replacing it deserves exactly as much of your attention as the heat did, possibly more, because the transition between the two is historically where some of the most damaging severe weather events on record have occurred. None of this means every heat wave this summer will end this dramatically, or that every region currently baking under high pressure is guaranteed a major severe weather event the moment their ridge finally breaks down. Some transitions are gradual and unremarkable, with the ridge simply weakening and drifting off without much drama at all. But the specific ingredients present in this particular transition, an unusually intense and long-duration heat dome, a strong contrast with the cooler air moving in behind it, and a broader seasonal pattern already primed by this year's developing El Niño for above-average severe weather, that are exactly the combination that has historically produced the more dramatic version of this handoff rather than the quiet one. We'll keep tracking every stage of this as it unfolds, where the severe weather threat shifts next, whether any of these systems reach that rare high-risk designation, and what the pattern looks like once this transition finally clears. Subscribe so you don't miss any of it. Drop a comment and tell me what the transition has actually looked like where you live, whether you've gone from brutal heat straight into severe storms in the last few days, and whether your area has ever had an SPC high-risk day called on it before. I read every one of these. Stay weather aware out there, and I'll see you in the next one.